Let's see one question from mechanics from recently conducted JEE Advanced 2019 from paper 2. So here we have this rod which is initially vertical and it is released from rest. Here friction given is sufficient so that there is no sliding. So this rod will rotate about this point. Okay. And as it is released from rest, question is we have to check the options when this rod makes an angle 60 degree. Okay. So when this rod makes an angle 60 degree with the vertical, we have to check all these options. Okay. So let's draw the diagram. This is the initial situation. Now no slipping will take place. So let's say after some time, it makes an angle 60 degree with the vertical. This will be the situation. Okay. So first of all, we can since this is nothing but pure rotation about this point. So I can find using conservation of mechanical energy what will be its omega. Okay. So I just need to find what will be the vertical displacement of its center of mass. Initially center of mass is at a distance L by 2. And finally you can see that if this angle is theta, this angle will also be theta, that is theta is 60 here. So this is L by 2 and this distance will be L by 2 cos 60. Cos 60 is nothing but half, so this will be L by 4. Okay. So firstly I can say that loss in potential energy is equal to gain in kinetic energy. Okay. What is loss in potential energy? That will be initial minus final. So initial is mg L by 2 minus mg L by 4. And gain in kinetic energy, let's say when it makes an angle 60 degree, the rod rotates with angular velocity omega. So its kinetic energy, since it is pure rotation, kinetic energy I can write it as half I omega square. So I about this point P is nothing but ml square by 3 into omega. Okay. So I can simplify this. This will be mg L by 4. This will be half ml square by 3 into omega. So m and L will be cancelled here, and this omega comes out to be, this 2 and 4 is also cancelled, this will be 2, so this will be 3g by 2l. Okay, under root of it. So as you can see, the same thing is given in the B option, so B option will be correct. Okay, let's find this alpha at this position. So at this position you can see that the two forces, friction and normal reaction, will be passing through point P. So if I want to write torque about point P, there won't be any torque due to friction and normal reaction because it will be passing through this point P. Only this mg will be having this torque. And what will be this torque? Mg into r perpendicular. So this will be mg into r perpendicular is nothing but L by 2 into this angle will be 30. So this will be L by 2 cos 30. Then this torque will be equal to I alpha. I about point P is ml square by 3 into alpha. So let's simplify this. M and L will be cancelled. This will be, so alpha will be 3g by 2 cos 30 is what? Root 3 by 2. So this is 3 root 3 g by 4. Okay. So this will be your alpha, and as you can see alpha is given as 2g by L. So this will be wrong. Okay. Now let's find this radial acceleration. If I know omega, radial acceleration we very well know is nothing but towards the center. This is nothing but AR. Okay. So this radial acceleration I can write it as omega square r. R will be nothing but L by 2. Okay. From this, the distance of the center. So this will be L by 2. Omega square we have already calculated. This is 3g by 2L multiplied by L by 2. So this will be 3g by 4, as you can see. Okay. So AR is also correct because it is coming out to be 3g by 4. Okay. Now main question or main part of this particular question is this C part. This is the most important part to understand. Okay. So let me draw the diagram again to understand this better. This is the initial situation, and it makes an angle 60 degree with the vertical, so it will be here, and at this instant it is rotating with omega. So there will be two accelerations here. One will be radial acceleration, other will be tangential acceleration. Radial acceleration we have already calculated. This is 3g by 4, and tangential acceleration will be r alpha. So here r is nothing but L by 2. Alpha we have calculated, so this will be 3 root 3 g by 4. So this is nothing but 3 root 3 GL by 8. This is 80. Okay. Now what are the forces acting on it? Normal reaction will be, let's say, vertically upwards. Mg will be downwards. And let's say it has tendency to slip leftwards, so friction is rightwards. Okay, I need to find this N. So I need to write what is the total acceleration in the vertical direction. Okay, so if this angle is 60, this will be 60. Okay, this will be 30. Okay. So I need to write what is the total acceleration in the vertical direction. So AT will have component in vertically downward direction. AR will also have vertical component in the downward direction. So net force in the downward direction must be more. So net force in the downward direction, I can write it as mg minus n. This is equal to m into net acceleration. Net acceleration will be what? Component of AT is what? 80 cos 30 plus component of AR will be AR cos 60. Okay. Now all I need to do is I need to put the value of AT and AR, which we already know. So if you put this value and calculate this n will comes out to be mg by 16. So therefore this C option is also correct. Okay, right. So this is an important question from mechanics, and as you can see, if you are conceptually comfortable, you can solve it very easily. Thank you.